Factors affecting performance. Among the key determinants of aircraft performance are its weight, the prevailing atmospheric conditions, the characteristics of the runway environment, and the fundamental laws of physics that govern the forces at play during flight. Aircraft weight. One of the fundamental factors impacting aircraft performance is its weight. An aircraft's mass, including the combined weight of passengers, cargo, and fuel, directly affect its ability to achieve optimal performance. A heavier aircraft typically requires longer runways for takeoff, increased fuel consumption, and may have limitations on altitude and maneuverability. Takeoff distance. Heavier aircraft have a higher inertia due to their increased mass. To accelerate this greater mass to the necessary takeoff speed, the aircraft requires a longer runway. The takeoff distance is directly related to the aircraft's weight, as a heavier aircraft needs more distance to achieve the required speed for liftoff. Lift requirements. Aircraft generate lift through their wings, and the lift force must counteract the aircraft's weight for takeoff. As weight increases, the aircraft must generate more lift, which necessitates higher airspeeds and longer runways to reach that speed. This is typically critical during takeoff when the aircraft must overcome gravitational forces. Fuel consumption. Heavier aircraft require more engine power to maintain flight. To support this increased power requirement, more fuel is consumed. The additional fuel consumption impacts aircraft's overall range and endurance. Heavier aircraft may need to carry extra fuel, which in turn increases their weight, leading to a cycle of greater fuel consumption. Altitude performance. Heavier aircraft may face limitations on altitude due to their increased mass. As altitude increases, the air becomes less dense, reducing lift and engine efficiency. Heavier aircraft may have difficulty reaching higher altitudes where the air is thinner, potentially limiting their cruising altitude and overall performance. Maneuverability. Increased weight can affect an aircraft's maneuverability, making it less responsive to control inputs. Heavier aircraft may require more effort from the pilot to execute maneuvers and may have limitations on the extent of their aerobatic capabilities. Atmospheric conditions. Factors such as air density, temperature, and humidity significantly impact an aircraft's aerodynamic capabilities. High temperatures and low air density, for instance, reduce an aircraft's lift and engine efficiency, potentially affecting its climb rate and overall performance. Runway environment. A shorter runway, or one situated at a higher elevation, may necessitate higher takeoff and landing speeds on longer ground distances. Additionally, the runway surface condition, whether dry, wet, or covered in snow or ice, can significantly affect an aircraft's stopping distance and ground handling. Fundamental physical laws. Aircraft performance is inherently governed by the fundamental laws of physics, including Newton's laws of motion and Bernoulli's principle. These laws dictate the forces acting on an aircraft, such as lift, thrust, drag, and gravity. A pilot's ability to manipulate these forces through control surfaces, engine power, and flight control inputs is central to achieving desired flight outcomes. By mastering these factors, individuals can ensure that aircraft performance remains optimized and responsive to the demands of each unique flight.